Hello, this is the Viking Initiative, and then still, this is about the Calc BC lesson for AP. And then today we're going to be talking about the Riemann sums. I wouldn't say this is one of the difficult concepts, but this is very common in like everywhere throughout the AP test. Like every year, I think there is at least one FAQ about those things. So this isn't very hard, but I recognize this as super important for the whole course about AP Calc BC. So let's start with like some definitions. What are Riemann sums? It's just like used kind of to estimate the area under a curve using shapes. And then I think in the course we've only talked about rectangles and trapezoids. So the more rectangle, the better the approximations. That's pretty obvious. And then there's four main types, which is the left Riemann sum, right Riemann sum, the midpoint Riemann sum, and the trapezoidal Riemann sum. And then here are some visuals. You could look at the left Riemann sum, like every point, look at here where this is fx is s squared in the first quadrant, we are assuming like everywhere that is from 0.5 to 1.0 is on the most left side of the interval. So for this, we take the interval as the always the leftward interval, such as 0 to 0.5, we assume every point is 0.0, and then 0.5 to 1, we assume every point have the same y value as 0.5. So there's for me four rectangles, which the first one is 0. And then for the right Riemann sum, we always use the right side, and always use the right side. And then I know there's something. I put it wrong figure, but it's fine. The right Riemann sum is always the right side, so this one is gonna go over here, forming like this rectangle, and then this one's gonna form here. So we always use right side. So everywhere from 0.0 to 0.5, it is the 0.5 side, and then everywhere from 0.5 to 1, you're using the 1. So always the most right point on the interval. And then the midpoint, we're assuming everywhere from the given interval, it is the middle. So like 0.0 to 0 0.5, we're taking 0.25 as the value. And then 0.5 to 1.0, we take 0.75 as the value. So we always take the middle value for this. And then the trapezoidal Riemann sum, it is like how we make a trapezoid using the two endpoints. Like the first endpoint is the most left from the interval, 0.0, and then the most right is 0.5. Or maybe you could look at maybe from 0.5 to 1 that is more obvious, which form a trapezoid. And then we use the sum of those trapezoids to just approximate the area under this whole curve. Like all of these, they will cause it will not be exactly correct. It is, and then it's not never like trapezoidal is the most accurate, even though it looks like one over here, but that's not always the truth. It is gonna change up depending on the curve, and then if it's underestimating or overestimating, it depends on its concavity. So such as if its fx is x squared, it is obviously concave up since the slope is increasing as increasing, yeah, it's concave up as we learn. So if we use like a left Riemann sum, we're obviously gonna underestimate, and then but if it's decreasing, and then our left Riemann sum is gonna overestimate. So it depends on the feature of the graph you're given. And this is really not tested. I'm just mentioning here, but I think you guys will go over it in class, and then we're gonna shift the focus on more important parts here. And then here are like just simple example, just same thing, estimate the area under what fx equals to x squared, same as the last figure. From 1 to 3, you're asked to use, I forget, 3 intervals, I think 3 intervals, and then, or 2, maybe, I forget. I forget which method. I wrote 3 here, yeah. Like we're trying just to do the area under fx is x squared. And then what we're gonna do is we're gonna try to all four just, this is straightforward, simple. Pause the video, try yourself. 3, 2, 1, okay. I think if you guys are finished, we're going to solutions. So first, the left Riemann sum, okay, we're using 3 intervals. The left Riemann, no, we're using four intervals, my bad. We're using 4 intervals. It is incorrect. You guys can read it, I'm so sorry. 4 intervals. It does, like, doing 3 is also fine. It's just a little difference. Okay, if the left Riemann sum, we take all the left endpoints, 0.11, 1.5, 2, 2.5, and then we use delta x, which is 0.5 for each of the width of the interval, and then we times those value, which will give you 6.75. And then the right Riemann sum using the right endpoints is 1.5 to 2.53. And then do the same thing, use delta x to times f 1.5 blah blah blah, which will give you 10.75. And then the midpoint is 1.25, those stuff. And then the same thing, delta x times f of 1.25 and f of all those values should give you 8.625. And then the trapezoidal sum is delta x over 2, because the trapezoidal sum is delta x times the f of x on the left side plus the f of x on the right interval, and then you divide it by 2. And here we just truncate all the 2 outs. And then you do the trapezoidal formula, should give you 8.75. I think this is relatively straightforward. I know I made a little mistake. It's fine. If you guys do 3, it's not gonna be as accurate. And then yeah, and then if you guys want to talk about, maybe we can think about which one is the most accurate. It should have x third over 3 after integration, and so it should be 9 minus 1/3. And like midpoint and trapezoidal rule is like the most close. It's in between of those two, I believe, the final value. So yeah, in this case, the midpoint and the trapezoidal rule would be the most close. Yep. And then the last thing is just some AP style questions, which just says a water is pumped into a tank at a rate of WT equals to this ugly function, liter per hour from 0 to 8 hours, where T is measured in hours. And then water is removed from tank rate multiplied by R of T, liters per hour, where R is differentiable and decreasing. Yeah, so what is removed at a rate? So R of T is a rate. This is what you're gonna like focus up. What is differentiable and decreasing on 0 from T to 8. And then those selected values for R of T is shown above. At time T equals to 0, there is 50,000 liters in water. So estimate R of 2 and show the work that leads to answer, indicate units. This is not about Riemann sum, but obviously you guys learned this, so I put it A also not here. And then B, use a left Riemann sum with 4 subintervals. Indicate by table to estimate total number of water removed from the tank during 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason. And then C, use your answer from part B to find an estimate of the total amount of value of water in the tank to the nearest liter to the end of 8 hours. So this is, A is just something that you want to know about concavity, which we mentioned like before. And then you want to use concavity to tell if it's an underestimate or overestimate in B after you're given the Riemann sum, just as what we practiced before. And then C is just like combining those functions together. They want to test if you actually understand what you're calculating about. Yeah. So I will give you guys like just pause video, do it yourself, and then 3, 2, 1, we're moving on to solutions. So number A is R of 2. If you want to estimate, obviously, since it's giving R of 3 and R of 1, use R of 3 minus R of 1 over 3 minus 1, which will give you negative 120 liters, which is telling you R of T is a decreasing function, or the integral of the R or integral of R of X is concave down. And then if you want to estimate the total number of this using a left Riemann sum, you always take the left endpoints. So if you see here, it's 0 to 1, its delta x is 1. So 1 times 1,340. And then delta x, which is 2. And then 2 times 1,190. And then you keep going on. 3 times 950, and then 2 times 740. And then here, which will give you 8,750 liters. Since R is a decreasing function, as we've seen here, so if it's decreasing, and then we always use like the left Riemann sum, just as we talked about, the left Riemann sum is gonna overestimate, because all the value of the left is bigger than the right. So this is gonna overestimate the final value. And then how are we gonna combine it together? So if we are like here at over 8 hours, if like the start is 1,500 liters, and then we have WT, which is pumped into, so we're not gonna time the integral of WT from 0 to 8, which is like how much water is in there. I'm pretty sure it's a calc question, so you can ignore this. It's about if this is pumped in there, then we're gonna add. And then if we estimate 80/50, then we minus this out. So this will give us the final answer of 487.86 liters. And then, yeah, I don't think this is that difficult to understand. I think, yeah, but it is very important. All those APFRQ is just exactly look like this one. It's only changing up the words. If you understand this one good, I think you guys will be very fine. And then, yep. And then if you have any more questions, just visit our Viking Initiative website and then join our AP Calc BC study group. There will be tutors on WhatsApp for more information and answer your questions. Thank you so much. And then that's just gonna be it for today.